I am Mini P. Jose, Assistant Professor of Bishop Special College for Advanced Studies, Palla. Today we are going to discuss the topic error detection and correction. During data transmission, there are several chances of errors occurrence due to several reasons like noise and other interference, etc. There are typically two types of errors. They are single bit error and burst error. In a single bit error, only one bit may change from 0 to 1 or 1 to 0. But in burst error, several bits may change from 1 to 0 or 0 to 1. For detecting and correcting errors, several methods are used. One of the main concept is redundancy. According to this, we will add extra bits along with the data for detecting and correcting errors. One mechanism uses parity bit adding, and at the sending side and the receiving side may check this parity, and if the bit is received correctly, that data will accept according to the protocol. According to this, data is transmitted as blocks, each of k bits. This type of coding scheme is called block coding. At the sending side, extra r bits are added to this k bits, and the resulting n bits are called code word. So at the sending side, data word is transferred along with the r redundant bits, and this code word is transferred to the unreliable transmission, and at the receiving side, this code word is checked by using a checking section, and if the data word is corrected and if no corruptions occurs, that data word is extracted and transfer to the upper layers. This is the basic concept. In this mechanism, there is another point. One is a linear block code. In linear block code, there is one extra property, that is, if the XOR operation of two valid code words creates another code word, we can call it as a linear block code. In linear block coding, the parity bit adding is considered, and another coding mechanism is cyclic code. But in a cyclic coding, cyclic shift operation of a valid code word creates another valid code word. This is also a linear block code, but this has one additional property, that is cyclic shifting of a code word creates another valid code word, that is cyclic coding. In cyclic coding, we are using a special mechanism called cyclic redundancy check. According to this, at the sending side, we will add some extra bits. Most commonly, extra 3 bits are added to a 4-bit data word, and these 7 bits are transferred to the receiving side. At the receiving side also, a checking or decision logic mechanism is performing. According to the decision logic mechanism, if the remainder bits are all zeros, that data word will be accepted, and there may not be any errors during that transmission. Now we are considering the cyclic redundancy checking mechanism. According to this mechanism, at the sending side, extra 3 bits are added, and the code word is transmitted through the unreliable transmission. At the receiving side, the code word is accepted and it is checked by using a decision logic, and if the remainder bits are all zeros, the data word will be accepted, otherwise it will be discarded. And we could consider an example for this. According to this, we are selected 4 bits as data word, and extra 3 bits are added by the sending side. At the center, 3 bits are extra added or augmented along with the data word, and at the generator section, these 7 bits are divided by using a common divisor, and in this example we are considering the divisor 1011, and after the division operation we will get a 3-bit remainder, and along with this 3 remaining bits the data word is transferred through the translation medium, and at the receiving side the data word is transferred to a decision logic, and at the receiving side also the same division procedure conducted, and after the division operation 3 remainder bits are considered. At this time these remainder bits are called syndrome bits. If the syndrome bits are all zeros, that data word will be accepted, otherwise it will be discarded. Consider the example of division operation at the sending side. We are using this 7 bits, that is 100100, and the divisor selected is 1011. At each step we are doing the XOR operation. So at this time we are considering 4 bits. This bit is 1 bit, so we could write 1 here. We could multiply this one with this number, and we could write 1011 here. Then we can do the XOR operation. According to the XOR operation, 1 will get 0, 0 or 1 we will get 1. These two are similar bits, so again we are obtaining 0 here. We are considering this 0 at this time, and here this bit is 0. We could write 0 at this position, and we will get, after multiplication with this number, this 4 zeros, and we are conducting the XOR operation once again. After XOR operation we are obtaining 0 here, 0 here, and we will obtain 1 here, and at this time we are considering this 0 bit, and 1000 is obtained. Here again there is 1 bit here, so we could write 1 at this time here. So again we are multiplying 1 this with number, and we are obtaining 1011 here. Again we are conducting XOR operation, and according to this we will obtain 1 here. Here also we get 1. Here there are similar bits, so we are writing 0 here. At this time we are considering this 0 bit, and the number now becomes 0110, and again this bit is 0. We could write 0 in this position, and 0 is multiplied with this number to obtain 0000, and again we are conducting XOR operation. After XOR operation we are obtaining 0 here. Here we will obtain 1, and here we get 1, and the 3-bit remainder is considered for transmitting along with this data word. So here we could consider 110 as the remainder bits, and these 3 bits are added to this 1001, and 7 bits are transferred to this receiving side. At the receiving side also the same division operation is performed, and after division operations 3 bits are also obtained as the remainder bits, and at the receiving side if the remainder bits are all zeros, the data word will be accepted, otherwise data word will be discarded. Thank you.